down to a fraction to a decimal. So from a fraction to a decimal, you're going to divide the numerator by the denominator. Okay, which one's the numerator? The top, nice. And the denominator, therefore, must be the bottom. Okay? So we're going to do the top number divided by the bottom. Now, I'm not going to worry about trying to do this without a calculator. Just chuck it in the calc. So you're going to do 2 divided by 5. Now, if your answer comes up and it still looks like this fraction, there's a button that has F.
No, it says S. It's S.
Oh, SD. Okay, so you're going to hit the button that says SD, and it changes it back and forth from fraction to decimal. Okay, so you're going to use that button. So who can tell me what 2 over 5 is? Kaya?
0.4.
Oh my.
That's what I do.
0.4. Let's get back to
the top.
So 7 over 11. Have we done that on the calc?
Yeah.
James?
0.63. Correct.
Now, did it just say 0.63?
Yeah. Oh, 2 dots on the 6.
There's 2 dots. So there's a dot here and a dot here. Can you all see that on your calculators?
No.
Yes? So if you do it and then have a little look, you should be able to see 2 dots.
Oh, yes, I see it.
Now, what they mean, oh, you remember that. It does carry on. Now, this thing here says that it's recurring.
So it goes
Not reoccurring, which some people say, so it's recurring. Now, if there was just one number that has a dot on the top, it means that that one number just keeps going and going and going and going. If there are 2 numbers on the top, what that means is that this number is secretly this. Oh, so you get the idea. I don't want to keep going because it all goes horribly wrong. So both of those numbers repeat. Okay, so it's 63, 63, 63, 63, 63. Goes on. Obviously, we don't have to write it all the time, but that's what that means. Okay, Sarah?
What is that?
Recurring. Recurring. R-E-C-U-R-R-I-N-G. Georgia?
I'm impressed if you don't put the dots, but we get it wrong.
That's a very good question. And if we've asked you to round it, then you wouldn't need to have it. Okay? And because if I was to round this, but you would have to remember that they were there. I would always look out for them, make sure that they're in there. So if it has been rounded, because if it was rounded perhaps to 2 decimal places, you'd have to remember that it was a 6 afterwards, wouldn't you? So because it was 1, 2, we'd go to the next number because that's a 6. It's actually going to be 0.64 to 2 decimal places. So you've got to remember that that means that they're both carrying on. Okay? Ladies, no. Leave the board alone, please. Okay, next one. Fraction to percentage. Fraction to percentage. Now, you've actually got a couple of ways of doing this, so I'm going to go through with both of them with you because one of the questions in the exercises uses this method. So one option is to change it to a decimal. So remind me, how do we change a fraction to a decimal? We've just done it. Maya?
Divided by 100.
It's from a fraction to a decimal.
Oh.
We just talked about it.
Ooh.
Abby?
So you put exactly how it is, 3 over 5, into your calculator. Then you click equals. You don't need to do anything. And then you press the SD button.
Good. So what are we actually doing? What's the calculator doing? It's calculating what, Madison?
The percent,
But what's it actually doing? What is this line in between the 3 and the 5? Divide. So it's calculating 3 divided by 5. That's what it's actually calculating, yes? So if we were to do that, we change it to decimal and then multiply. Oh, you're
Yeah,
So,
that's
so we're going to do 3 divided by 5. What's 3 divided by 5? 0.6. And then we're going to multiply that by 100. How do we multiply things by 100? Think of a sneaky method. We don't need the calculator for that bit. So if I move my decimal point 2 places to the left,
Right.
it's going to get even smaller, isn't it? So if I want to multiply by 100, which way do you think it's going to go?
Yeah.
To the right, okay? Again, if you want to have some zeros over here to help you, so you don't get confused, I'm moving 2 places. 1, 2, so I've got 60%. Okay, so that's my first example. And the next one, 12 over 35. So we need to change that to be a decimal first. So can we change 12 over 35 to be a decimal? Whoa. Okay.
Huh?
Maya?
Wait, Miss Harrison, I'm
Oh.
still confused about the first one.
Okay. Alright, so this one's super complicated. We've got 0.3 and then 428571, and that's all recurring. Okay, so what did we say we have to do to our number? We have to now, Georgie? Multiply by 100, yes? So we've multiplied by 100, so I'm moving my decimal point. Sarah, how many places?
2.
2 places, good. Where is it going to end up?
It's going to go, after the 4.
Good girl. So we're going to have 3, 4. Oh,
I thought that, is it the decimal on top of the 4 or the 2?
it's a 4.
I have a question about the recurring thing, how they have the little dots over top. So at the end you would write 41414141.
Well, we're gonna talk about it now. We would probably round this to either 3 significant figures or 1 decimal place, probably. So we're going to talk about rounding now. Now we know that because the dot is above the 4 and the 1, you're going to have this list of numbers, and then it's going to keep going 428571, 428571. Yes.
Oh,
But we
so
don't
it's every,
really need to worry about that so much.
it's every number in between the 4 and the 1?
Correct, including the 4 and the 1.
Recurs. So
Yes.
in between the 2 numbers,
Yeah.
every number.
Exactly.
But if the dot was just over the 4, only the 4 would be correct.
Yes.
All the numbers?
That's exactly it. Yeah. So this is our number. So Sarah's told me already that we're jumping 2 places, so it ends up here. So if I were to round this to 1 decimal place, we're interested in this number, aren't we? And this number. What does the 8 do to our 2? Aya?
It makes the 2 go up by 1 decimal place instead of the 5.
Careful, which one are we possibly changing? It's not going to be the 4, it's going to be the
2.
The 2.
Oh, I said the 4.
Well, you said it becomes 5.
Oh, well, I meant 3.
That's exactly what I think you meant. So that's 34.3. Now, I'm actually now going to focus back up on this one here, just to show you another way of doing it, because sometimes this method, it makes it a little bit easier. So I'm going to look at 3/5 again. We know the answer, we know it's 60%. Okay? Another method is to say, well, this was a 5. To be a percentage, what would I like my number to be out of? So what do I know the percentages are always out of? Maya? 100. Okay? So we all know about equivalent fractions, don't we? That we can change this fraction here to be a different fraction by multiplying the top and the bottom both by the same number. Okay? So I could change this to 30 over 50. Okay? I could change it to 6 over 10. All of these are what we call equivalent fractions. So if I were to try and change it to be something over 100, what would I have to do to my number? How do I get from being a 5 to being a 100? What would I have to do to it? Good. I'd have to multiply it by 20. You all see that? So if I wanted to go from being a 5 to 100, I would multiply by 20. Well, the rule for fractions is whatever I do to the bottom, I must also do to the top. So I would multiply that by 20. And what's 3 multiplied by 20? Vasika? 3 multiplied by 20. So remember we would, in our heads, do 3 multiplied by 2, which is, yeah, and then we'd add our 0. Now, because it's over 100, I know it must be a percentage. So what's my percentage? 60. And that's what we had before. Okay?
So that'll be the way.
So that's a different method. Sometimes it's much faster because if I say to you I've got 8 out of 50, that's really quick to make over 100, isn't it? What would I do to these numbers to make them something over 100? Multiply by 2. So what's 8 multiplied by 2?
16.
So this must be 16%. So 8 over 50 is 16%. Okay?
Oh, yeah.
So it's a sneaky, faster method. If you're comfortable with the green side, just go with that each time because that works for all of them. But the red side, the red half, that's sometimes quicker. All right, let's have some practice.
Wait.